All right. In this video, let me tell you how to implement the binary tree in C++. Okay. So in the previous videos, you may have got an idea about trees. You know what are trees, how do they look like, and how to approach with trees. Okay. But that won't be enough. All right. So here we'll try to implement binary tree in a programming language in C++. In C or C++, I'll I'll show how to do that. Make sure that you can do the same in any programming language that you want. Okay, if you want to do that in Python, you can do. I'll tell you the idea in Python too. Okay, so you can use any programming language you want. You are not constrained to use C or C++, but in this course I will follow C or C++, but I'll be clearly explaining all the algorithms for the problems that I'm going to solve, so that you can implement it in Python also, Python or JavaScript, in any programming language that you wish to work for, right? All right. So, implementing binary tree in C++, I'm going to use some concepts for it. First one is a linked list. Okay. I hope you know about it. Linked list is a linear data structure. All right. So I'm going to use it in a non-linear way. Understand that tree is a non-linear data structure because it's not gonna have one after the other, or like an array or a linked list or a stack or a queue, whatever you call. It's not gonna have the elements one after the other. Rather, it's gonna be a complex structure. It's gonna be hierarchical. Okay. It's gonna be the hierarchical data structure, okay, that we follow. All right, you know about it. Okay, so I'm going to use linked list, or I could say link approach. Okay, linked list approach in order to implement trees. It's not going to be the same exact linked list what you have studied in your data structure concepts. It's not going to have one head and one data. It's going to have it's not going to have one next pointer and one data field. Okay, a linked list will be having two fields, right? Basically, if you have it, it will be having one data field, and it will be having one next pointer or next field, which will hold the address of the next node. Okay, which will hold the address of the next node. So in each linked list, there will be nodes. Okay, in each node you will get two fields. One is called data field, and another one is the next field, which will hold the address of the next node. Okay, that's how they are linked together. That's how they are linked together. Okay, but in this approach, please try to understand that I'll be having one data field here, and I'll be having two, pointer fields. Okay, they are called. Let me call them as pointer fields. One is called as left, and another one is called as right. Okay, so I'll be having two pointer fields basically. One is called as left pointer, and another one will be right pointer. Basically, one will be connected with the left node, and another one will be connected with the right node of the tree. Okay, I hope you got it. Let me take a simple binary tree example. Oh, okay, all right. Oh, if this is the binary tree, simple binary tree. Let me say this is 1, and this is 2, and this is 3, right? So as you all know that here this is called as head or root. Okay, head or root. Okay, and 2 is connected to 1 as a left node, and 3 is connected to 1 as a right node, right? As a right node. All right. Now how will I implement this as a linked list approach? Okay, as a linked list. All right. So let me have one node here. Okay, whose data will be 1 basically. All right, and let me have another node whose data will be 2 basically, and this node will be having a data of 3. All right. Here if you see here if you see the left field of this particular head or root node will be pointing to the left node. Okay, will be pointing to the address of the left node. For instance, let's say the address of this particular node, because this node will be stored in our data, right? Of course we'll be allocating memory for it using our malloc function. Okay, I hope you know about the basic concepts of linked list, then only you will be able to understand it. Okay, so this course is for intermediate stuff programmers, because you should be able to understand this. If you are a beginner in DSA, okay, if you understood the concepts of linked list, dynamic programming, I mean dynamic memory allocation, then you will be able to understand it easily. Okay, let me say this is stored in the memory address 1001. Okay, let me assume like that. This address will be usually a 32-bit or a long number, but let me assume it as 1001 for my easier computation. Then this will be holding a value of 1001. That is not actually a value, that is nothing but the address of the left node. Okay, address of the left node, so that it can easily locate the next the left node. Okay, and here let me say the address of this node is 2001. Alright, address of this node is 2001. Then it will be storing a value or address of 2001 so that it can point to the right node. Okay, so that it can point to the right node. Now you may ask a question, then what are the values that are stored here, that are getting stored here? Okay, what are the values here? Okay, here at these points, what are the values? Okay, since these since these nodes 2 3 are leaves, okay, they are called as leaves, which means that they are they form the end of the binary tree. Okay, they form the end of tree. Okay, you know, after the leaves, if you go beyond the leaves, we do not have any connection. Okay, we do not have any nodes. All right, they form the end of the tree. That's why they are called as leaf nodes. Okay, so when you talk about leaf nodes, they form the end of the tree, so they will simply have a value null. Okay, they cannot, they cannot point to anything. They can have only null. All right. Okay, so please have a note on this. All the leaf nodes left and right pointer will be having a value of null. All right, this will be very useful to write your base cases while implementing this. Okay, so please try to understand that the left and right nodes of the leaf node, left and right fields of the leaf node, okay, of the leaf nodes, they will be having a value of null. Only the leaf nodes. Okay, the left and right fields of leaf nodes. Okay, all right, let me try to produce one more example. Let me say 1, let me say 2, 3, 4, 5, 6, 7. Okay, this tree looks somewhat bigger compared to the previous one. In that case, my my representation would be like this. Okay, now 2 and 3 are not leaf nodes. Please try to understand, 2 and 3 are not leaf nodes. They are internal nodes. Okay, any node other than the leaf nodes are called as internal nodes. They will be definitely having the left and right pointers. All right, any one of these or both of these. Okay, sometimes you can you can draw like this also. This is also possible. Okay, in that case the right node will be null. Okay, let me draw like that. Okay, let me assume that this is my tree. Okay, in that case the right node will be null, the right node alone will be null, the right field will be null, the right field will be null because it's pointing to nothing, so which is symbolically represented as null, which means it is pointing to nothing. Then here you'll be having 4 whose left and right both will be null. Okay, here you'll be having 6 whose left and right both will be null. Okay, so the left will be connected to here, the left of the node 3 will be connected to leaf node 6, and right will be null again. Okay, right will be null again, right? All right, this is possible actually. All right, so for implementing a single node in a linked list, I'm going to use something called as a structure in C++. Okay, you will be knowing it already. So I'm going to use structure in C++ in order to implement a particular node. Then I will create copies of lot of structures. Okay, so first of all, I'll be creating a structure that is going to act as a user defined data type. Okay, you know that whenever you have a data type, you can create a lot of variables with the data type, right? Say for example, integer, float, a lot of types are there, and you can create actually your own variables, and you can store your own values on that, which are of that particular type. All right, so now I'm going to define my own data type because it's going to be my own data type. It's going to be user defined data type. Okay, as you can see here, it should have a left field, right field, and a data field. Okay, so I'm going to define a data type like this, which will be having a left field, a right field, and a data field, right? Using that concept called as structures in C or C++. Okay, both more or less they remain same. All right. Okay, so that is structure, and you can also implement it using a class whenever you go for Python. Okay, if a particular language, if the language that you are working on supports OOP, object oriented programming, then you can implement this idea, or you can implement this node using a class. Okay, you can create a class. It's basically going to act as a template. Then you can create a lot of objects which are going to act as all your nodes. All right. Okay, let me tell you that also if time permits. Okay, because some of you might be working on Python or some other languages. Okay, that's completely fine. Okay. All right, so let me give you the structure what I'm going to use. So let me say struct node, because struct is a keyword to define a structure or to declare a structure. Okay, struct node, and it's going to be a self-referential structure. Okay, it's a special type of structure called as self-referential structure, which means that because a structure variable here, if you talk about a structure, it is a structure variable, it is pointing to another structure variable, right? It is pointing to another structure variable. That's why it is called as self-referential structure. It is referring to its own type, right? A type, a structure type referring to its own type. That's why it's called as self-referential. Okay, self-referential structure. Let me call it as node. Then let me have int, okay, data. So it's going to be the data field first of all. Then I can have one more variable. Let me call it a self-referential pointer, because it's going to be holding a pointer variable. Okay, so struct node left pointer, and again it's going to be struct node right pointer. Okay, I will soon jump into the coding environment. Don't think that I'm going to work only in this notebook. It's not like that. We will try to implement it as soon as possible, but let me give you the gist of it. Okay, all right. Here, what do I mean by this particular statement? It means that the left is a pointer variable. Okay, that is what I mean by this hashtag symbol. Left is a pointer variable, but what does it point to? Okay, it points to another structure only, right? It points to another structure variable only, right? So that's why I have put struct node again here. Okay, it is of type struct node. Okay, the data to which the pointer variable left is pointing to is again a structure. All right, it's again of type struct node only. That's why I put struct node hashtag left. Okay, the same I should follow for the right also, because they mean the same. Okay, all right, so this is going to form a single node in our this is going to form a single node in our tree. Okay, in our linked approach. Okay, in our linked approach. Now to create multiple nodes like this, let me say I'm creating a single node. Let me say this is just a template. Okay, this is just a template. Okay, this is just a template. Whenever you are creating a node of this particular type, using this template you can create as many objects you want. This is just like a blueprint. Okay, using this blueprint you can create as many objects you want, all right, as many variables you want. Okay, so please make sure that when you create a struct node variable, you have to allocate memory to it. Okay, you have to allocate memory to it. You have to you know uh, allot a space in your programming memory, in your data memory, so that it can actually store its own values. All right, so inside my main function, let me assume this is my main function. Okay, time being I'll be writing like this. Okay, don't okay, let me write it like this. Okay, what main. Here whenever I create a variable of type struct node, let me call it s1. Okay, let me call it s1. All right, it's gonna be my first node. Let me assume like that. I will be allocating memory using a particular function called as malloc function. All right, malloc function, which will be used for dynamic memory allocation. For that I have to import a an inbuilt header file, a library called as standard library, stdlib.h. Okay, stdlib.h. I have to include that library because that library only contains, that header file only contains this malloc function. Okay, all right, that's fine. Okay, malloc, inside which you have to provide the size of the memory that you want to allot. Okay, we don't know the size exactly. We will not be involving in calculating the size of the structure. That is not at all necessary. You can simply use the size of operator in order to get the extract the size of it. Okay, it is not necessary for us to calculate it manually. Of course, it will depend on system to system. So what I can do is I can simply use the size of operator. It's more of like a function, but we call it as an operator, in order to return the size of this particular template. Okay, in order to return the size of this particular template. So what I will be doing here is I will simply pass the struct node, the name struct node. Okay, the name struct node. All right, okay, that's it. Then in front of which what I can do is I can do my typecasting. Okay, so what malloc will basically do is it will try to allot this particular space for you. For example, if struct node is of let me assume that struct node is of 8 bytes, or okay, let me assume that it is 8 bytes, then 8 bytes of memory will be allocated. 8 bytes of memory will be allocated, and malloc will return the initial pointer of those 8 bytes. Okay, if 8 bytes of memory is allocated in your heap, basically allocated in your heap memory, then the initial the initial block, right, the initial block's pointer, the address will be taken. Okay, the initial block's address will be returned. That's what malloc usually do. The initial block's address will be written. Okay, so because you have to know the address, okay, you have allotted a memory, so you have to know the address. All right. Okay, so the address will be written, but that address you have to typecast it as a node address. Okay, because it may point to it will usually be a void pointer. I hope you know what is a void pointer. So you have to typecast it as a struct node again. So struct node star, I have to say struct node asterisk in order to typecast the address. By doing this, what I'm saying, trying to prove here is, I am trying to point to a node only. Okay, so I'm using basically an address. That address contains the node point, I mean struct node only. Okay, that address contains some values which will be of type this struct node. Okay, which will be of type struct node. All right, that is what I'm trying to say here, because it's gonna return a void pointer. Okay, that's why I'm doing like this. So you have to do the same step for how many nodes, how many nodes you are creating. For example, here I have node number 1 2 3 4 5. I have 5 nodes here, and I have to repeat the same statement for five other nodes. Okay, I have to repeat the same statement for 5 other nodes. Okay, I have to repeat the same statement for 5 other nodes. Okay, that we will do later. So I have created one node only. Now let me tell you how to allot value to this node. So this, using this particular s1 variable, I can access three things. Okay, I can access three things. Let me take it as a comment. Okay, or let me write it here. Using this s1 variable, I can access three things. Okay, because it is of type struct node, right? Struct node has three data members: data, left, and right. So using this s1, I can access three things: data, left, right. Okay, I can access three things using this s1 variable. But how do I access it? How do I access it? To access it, you have to use this arrow operator. So this operator, you exactly have to use this. So it's gonna be s1 arrow data. Okay, you can access this data field. If you say s1 arrow left, you can access the left field. Okay, so using this arrow operator, you can access the particular field in that node. Okay, in that node, if you want to access a particular field alone, then you have to use arrow operator. Okay, s1 denotes the whole node. Okay, s1 denotes the whole node. S1 denotes the whole node. If you want to access the particular field in that particular node, then you have to say s1 arrow data. If you want to access the left field, you have to say s1 arrow left. Okay, and let me say this node is s2. Okay, this node is s2. This node has an address called s2. Then if I say s1 arrow left equal to s2, then whatever is the address of s2 will be assigned to s1 arrow left, which means that now s1 left will point to s2. Okay, s1 left will point to s2, right? That is how it exactly works. Okay, so to allot a value of 1 to it, let me say s1 arrow data equal to 1. So now 1 will be allotted to s1 arrow data. Then if I say s1 arrow left equal to null, by default it is null only. If you want, you can reassign it. Okay, then now 1 becomes a leaf node. Okay, this particular s1 node becomes a leaf node. Okay, because as you can see, both the left and right pointers are pointing to null only. All right, I hope you got the flow of it. Now let me try to code it in C++ in the coding environment, so that you will be able to understand it easily, right?